Hi guys, today I'll be demonstrating how to differentiate using separable equations. Let's start us off with the definition, which states that a separable equation is a first-order differential equation in which the expression of dy of dx can be factored as a function of x times a function of y. I know it's quite a mouthful, and if you're confused, that's fine, I were too, but the concept is very simple. Trust me. So, having said that, let's begin. The first example that I'm going to solve is this one. dy over d theta equals to e to the y times sine squared theta over y times secant theta. Our first step would be to separate the variables by writing everything with the variable y on the left-hand side and everything with the variable theta on the right-hand side. Then we take the integral of both sides. At this point, we have learned everything new in this section. From now on, it's just repetition from the past. So let's begin by taking the integral on the left-hand side first. For this one, we use integration by parts, meaning we let u equal to y and dv equal to e to the negative y dy. Now we just fill in the matching counterparts and follow the formula. That's the integral of u dv equal to uv minus the integral of v du. We substitute the original expressions back, and by cleaning up on the negatives, we get negative y e to the negative y plus integral of e to the negative y dy. All that's left to do is to integrate the last part, and we have our result, which is negative y e to the negative y minus e to the negative y. Now that we have figured out our left part, let's start working on the right. For our sine squared theta over secant theta, we can put in some of our trig identities to use. As we can see, 1 over secant theta equals to cosine theta, so we can rewrite that as the integral of sine squared theta cosine theta d theta. We use u substitution in order to help us solve this. Now, if you have forgotten how to do u substitution, I have made another video describing a problem with that, which I will link at the end of this video. Let's let u equal to sine theta, so du will equal to cosine theta d theta. We perform the integration after having it rewritten in terms of u, and we get 1 over 3 u cubed plus c. At this point, we can substitute our sine theta back into as u, and we have 1 over 3 sine cubed theta plus c, our right-hand solution. We are done with this problem. Our result is negative y e to the negative y minus e to the negative y all equals to 1 over 3 sine cubed theta plus c. There is nothing more we can do, and that is our answer. Now that that's done, let's do one that we have to actually satisfy a given condition. In this case, we have du over dt equal to 2t plus secant squared t all over 2u, and our given condition is u of 0 equals to negative 5. We start off exactly like the other one by separating the variables, and we have 2u du equals to 2t plus secant squared t dt by separating the u and the t's on their own sides. Now it's time to perform the integration on both sides, and with this problem we are quite lucky because it's just a straight out integration. 2u du becomes u squared, 2t turns into t squared, and secant squared t becomes tan t, and of course the plus c. We would usually start solving for u right now. However, in this case, we still have to find what c is using our given conditions. By replacing the u with negative 5 and the t with 0, we easily solve for c, which becomes 25. We now have c, which allows us to complete the problem by writing u squared equals to t squared plus tan t plus 25. The one step that is left for us to do is to solve for u. After taking the square root on both sides, we are left with u equals to plus minus t squared plus tan t plus 25. Since our u of 0 equals to negative 5, which is in the negative range, our u will equal to negative t squared plus tan t plus 25. And that is our answer. As promised earlier on, here is the link to the u substitution video, alongside of 2 more videos that I have made about trig substitution and curve sketching. If you click on the appropriate boxes, it shall take you to those videos. Thank you for listening and have a great day.